right? Basically, I'm going to give you a simple question to do, and then which has all sort of calculations, what we have already, what we have done so far, and then we'll be learning a new concept called limiting reagent. What are we going to learn? Yeah,
Limiting
what are we going to learn?
reagent.
Limiting reagent, right? So percentage yield, stoichiometric calculation were the most difficult questions those days, right? And then we are going to get limiting reagent, which is the same concept, yet uh, might confuse you with the concept. However, now there are students who join using the mobile phones, and probably after long time we are switching back to online. So you might, I mean, you don't have the facilities you had earlier because the time that you had compulsory online. That's why even this power problem is a big issue because you are not ready for this. So then please make sure you are going to be ready for all these situations. Uh, right, be aware of that. There can be electricity cut, there can be riots going on, curfew, and all these things. Right. All right, let's get started. Uh, Hope everyone can see the screen. Those who are not in the video, can you quickly reply in the chat that you can see the screen? Hurry up, I want your interaction. Now, those who have put the camera on, I can see that from your body language. So then I can quickly realize it. Those who are not having the camera on, you have to always uh, active in the chat, send in me the responses. Okay. So Ranu reply, Binu reply. Okay, let's move on. Which statement about the material used for aircraft bodies is correct? Aircraft bodies are made from an aluminium alloy because pure aluminium is too soft. Not very, you can't say it's wrong. So then you're not sure, right? You know that it's lightweight and but strong aluminium, right? So there can be more reasons than this why we use aluminium alloy for this. Therefore, let me keep that question mark and then move to the next one. Pure aluminium, because of its high melting point, right? Actually, it's not made of pure aluminium. You know that I clearly said pure metals have weaknesses, right? They have some weaknesses. They are not like fully compatible for our day-to-day use, right? And therefore it's gone. Pure, then very easily, right? So all three are gone because you are not using pure aluminium, right? And it has a low density. True, it has low density, but we don't use pure aluminium for that. It is resistant for corrosion. Yes, of course, but we don't use pure aluminium, right? It's an aluminium alloy. So the reason is because it's too soft. Therefore, the answer is A. If you have any problem with that, you can argue, right? And next one is another interesting example. Let's have a look at the next one. Which structure represents that of an alloy, right? For you to have like an alloy, right, we basically need some metal ions with the same size in a regular structure and some metal ions in irregular structure, and then you will have electrons all over the place, right? That's how it should be. So in on the answer A, you have all the metal ions with the same size. So it's not an alloy. Not an alloy. Not only it's not an alloy, it's a pure metal. It's a pure metal. I'm sorry about the handwriting here. The reason I'm not using my smart board, I am now using a writing pad. The pen like very easily slides, I mean glides. So then very difficult to write like the way I write in the smart board. Okay, I'm really sorry about it. Can't help. Okay, so why B is wrong? I would say B is wrong. Why? Can anybody guess why B is wrong?
So the positive ions are the same size.
That's a good point. Yes, positive ions are same size. There's another reason why it's wrong.
So they don't have any in a proper order.
Correct. So then, what sort of metal is this? I mean, it looks like a metal because you have cations and delocalized electrons. So it's going to contradict with the metal structure because there is no order. But can't we have a metal with no order in the cations? So those are the things that you have to think. Come on, others. Can't we have a metal, right, which has the cations in no proper order? Netuki, මොකද කියන්නේ?
So for it to be bonded by metallic bonding, the attractions have to keep them in a regular arrangement, right?
All right, Hari. So I'm asking, can't we have, right? I don't need an explanation. Give me one short answer, black and white answer. Can we or can't we? A metal like this. වැරදුනාට කමක් නෑ නෙතුකි. You know that?
No.
No, okay. We can't have a metal like that. Okay. So I won't. Janila, what do you think?
Yes, so you can have a metal with that structure.
Okay, so you are confusing me. You start the answer saying yes, right? And then you are saying you can't. Okay, let's say you can't have a metal like this structure, right? What about Vidul? Vidul මොකද කියන්නේ? ඔය B වල තියෙන structure එක වගේ metal එකක් තියෙන බැරිද?
Can't.
Can't. Metu?
Sir, you can't.
You can't. Yes, okay. Straightforward. Netil? Netil?
So you can.
You are saying you can. So, okay. Now here we have contradicting answer. Netil, can you elaborate?
So not sure, but I have a feeling.
Okay.
Yes.
I'm not asking your gut feelings. I'm asking you, right? I'm asking you through your knowledge. You know, if I'm asking a question like this, there is something. That's what you're thinking, Netil, aren't you?
Yes, sir.
Yes, okay, but that's not the case, right? You must answer with your knowledge. Then even though you go wrong, if there's something you can correct in your knowledge, is that clear?
Yes, sir.
Okay, work like scientist, okay, scientist. Scientist, okay, according to what I know, you say no, yes or no, right? That's it. You can't say no, but I think because the way you ask in the question, it can be like aim back.
Yes.
All right. Let me take you to one of the very traditional story in our country. Whether what is the next month poya lamai?
Poson.
Okay. Some of you are thinking a lot. My goodness, what is the next month poya?
Poson.
Poson. There is a nice story about even though those who are not Buddhist, don't take this as like a religious story, right? There is a nice story about this Midhu Hamduruo and the conversation with Midhu Hamduruo and Tissa, King Tissa. Do you know that? There is a nice conversation with Midhu
Yes, sir.
Hamduruo and King Tissa. What is that? Yeah,
තිස්ස.
Oh, තිස්ස කියන එක විතරක් නෙමෙයිනේ. මෙතන තිබ්බ හැන story. I know I can't draw this nicely. I'm sorry about it. Can't help. Okay. Right. Can you remember the Mihidu Tero asked some
Yes, sir, about the mango tree.
About the mango tree. A question to Kian. Do you know the question?
Sir, හරියටම මතක නැහැ.
හරියටම මතක නැහැ. Are you a Buddhist?
Yes, sir.
All right. Okay. What to do? That's what has happened to us. Come on, that's all right. I told you not to take this religious. Anyway, so there is a mango tree here. All right. Okay. Anyone else remember this? Sandev Matakada? Netoki Matakada? Now you may be wondering how this is related to the lesson. Right? No, this is related to the lesson. Otherwise, I won't take this into account because I can see what something that King This Mihidu Tero wanted to check King This's intelligence. He asked these questions. So this is not religious questions. Okay, right? Yeah, Nituki, do you remember the questions?
So he asked what this tree was called.
All right. Okay. What is this tree? What was the answer? Yeah.
Sir, mango tree.
Mango tree. So the king said, "Ayyo, maybe king may be thinking, oh, who is this fellow asking me such stupid questions, right? This is a mango tree." What was the next question?
So he asked if there were any other trees other than mango trees.
No. He didn't ask like that. He asked, are there any more mango trees?
So the next question was, like, are there any other mango trees beside this mango tree?
Mango tree, yes, correct. Right, mango tree. What was the answer of the king?
Sir, he
Yes.
said that
Yes.
yes, many other
Yes,
mango trees
sir.
are there.
Yes, sir. There are hundreds of thousands of mango trees. There are there is lot of mango trees. Lot of mango trees other than these mango trees. Okay, now, those who are not Buddhist, you don't have to take this as religious. This is a very logical set of questions. Okay, right. Next question. What is the next question?
So the next question was, like, is there any other trees other than this mango
Other
tree?
than those mango trees. Other
mango
than
trees, other mango trees. Yes.
okay. Other than those mango trees. Now, those who know the answer for the last question, please don't answer. Okay, I'm not like checking your knowledge or I won't. It's not that I'll be impressed when you give the answer. I want those who don't think about this to get like, to think about it. Okay, other than those mango trees, are there any other trees in this forest? Any other trees in this forest? Any tree? Are there any other trees? So what was the answer? This is not the last question. Don't worry. This is not the last question. What was the answer? Yeah, come on, guys. Yo.
Sir, the answer was there are many trees, sir.
Yes.
But
Yes.
there are mango trees.
Sorry.
Sir, the answer is there are many trees, but they are not mango trees.
Yeah. Yes, sir. Yes, sir. There are so many. There are so many other trees. All right. Okay. Here is the last question from Thero. Right now, some of you know the answer, so then don't give. Right. The last question is, except for those trees, and those mango trees, are there any trees in this forest? This is the last question. Right? So those who don't know the answer, I mean, those who know the answer, please stay silent. Others try. What is the answer for this? Especially those who are not Buddhists. Can you answer this? If you know the answer, honestly, don't answer it. Others try. I want everyone to give me an answer in the chat, those who didn't know the question. Except for these, those trees, that means non-mango trees, and those mango trees, are there any more trees in this forest? Lashen saying no, there aren't any other trees. Very good, Lashen. Yeah. Someone else? You may go wrong, that's all right. May okawath impress karanna නෙමෙයි මේ ප්‍රශ්න අහන්නේ. To learn something. No trees, no trees more anymore. Shenon, that's good. Okay. No trees. Okay. Right.
Say yes, but not in this forest.
No, this forest. Nethil, you're always giving me some terrible responses. Okay, right? Luckily, like King Tissa didn't think like that. Hari. Okay, now I got like answers from many of you, right? Kitumi, did you know the answer? Oh, you didn't give me an answer. What? No, yeah, Kitumi, not sure.
Yes, sir.
Yes, the no, the විතරනේ කියන්නේ එච්චරනේ කියන්නේ වැරදුනා නැද්ද? හරි. Okay. මොකක්ද answer එක මේ ජනිල?
I'm not sure myself.
ඉතින් එහෙනම් ඉතින් අනිත් උත්තරේ දෙන්න එපා. Yeah, Netuki, what was the answer for King Tissa?
Sir, this mango tree?
Yeah, he said, yes, sir. If you exclude all the other trees I told you in the question number 3, and all the other mango trees in the question number 2, right? There is a tree that you didn't focus, that is the first mango tree, the mango tree next to you. Did you understand? Right? So what did Thero test from King? When the questions become harder, more difficult, the content become more complicated, whether the king is going to forget the simple things or the beginning. You get my point? Right? If the king can't handle that, then he can't handle the country, or he can't handle the religion. Is that clear? Right? If you forget the simple stuff, or the beginning, right? The first steps, when you dig deep in any content, you forget your basic rules, right? Then that person is not very intelligent to handle things. It's just like fake intelligence is there. Do you get it? So this is what you guys, what happened to you guys? When you dig deep in metallic bonding, alloying, new lessons, you forget when a metal is melted, when it become a liquid, you can have something like this, right? It was in kinetic particle theory. So you forgot your first mango tree, didn't you? Right? This is one of the very, very common reason why you guys don't get enough marks in the exam. Why? You study all the hard stuff, and the exam question is testing very simple thing, and you forget your kinetic particle theory to answer that moment. Not that you don't know, you don't focus on that. So this is, now give me an example for such metal here.
Gallium.
Okay, so what is the like most known one is mercury, right? So this is a This is a metal like mercury structure. You get it, right? Okay, so you guys agree with this set of questions, how like psychologically or like educational important? Have you ever thought of this when you learn this in your Buddhism classes? The how
No, sir.
intelligent and the logical, like what sort of things we can learn, right? I'm happy if the other students in the, I mean, students in the other religion can share such ones. I know a few from Hindu and from Muslim, right? Islam, right? If you can share such things, we can learn from them, right? So kind request. Okay, so learn your religion in a more intelligent way. All right. Okay. Right. Part C. The answer is acceptable. Why? You have metal cations in a kind of a logical, I mean, the what you call the ordered way, and there are like two, I mean, few cations small and some cations big, so they are not going to like slide easily. So this is the alloy. You got the point? Okay, and here part D, it is not a metal at all. Can you tell me what kind of a compound is this? I mean, what kind of a substance is this? Very good. It's an ionic compound. It's a compound. It's an ionic compound. Why do you say it's an ionic compound? You have cations plus what? Anions. You get it? Okay. Today I need someone to give me screenshots. Quickly give a screenshot, and others please confirm whether you understood the discussion of these two questions quickly. So at the end, when you look at these questions, they look all similar, right? Easy, right? So then please do not forget these things and fail to get good marks in this monthly test. All right, really important. Like you guys have to build the confidence back after the semester paper shock, right? You have to rebuild your, confidence. By the way, 1, 2, 3, 4, 7, and only 13 students are in the class, right? Today. Okay, so let me go to the next question. The physical properties of copper can be explained in terms of metallic bonding. Describe with an aid of a label diagram a metallic bonding in copper. They ask metallic bonding in copper, but I recommend you explain both bonding and structure. Then it's easy, right? So you draw few cations here in a ordered manner. I'm really sorry, I can't draw in such a clean way because of this writing thing. Nothing wrong with that. I am not still skillful with that. Okay, and then this is cation. Make sure you label them electrons. When you say E, it means electrons, but better you write, okay, delocalize electrons, right? Delocalize electrons. And then with the aid of label diagram, the metallic bonding copper, right? Now, they ask us to explain the bonding. So you can say metal, you can write the first point, metal cations release, rather not metal cations, metal atoms. Metal atoms release their last shell electrons. Last shell electrons. To form cations and a sea of electrons, or yeah, and a sea of electrons. A sea of electrons or delocalized electron cloud. But that is okay. This is 1 mark. The diagram 1 mark. This is 1 mark. Then what's the next mark? The next mark is to explain the interaction between the electrons and the cations. So there are strong electrostatic attractions. Electrostatic attractions. Right, between cations and electrons. Cations and electrons are called metallic bond. Right. So they ask bonding, like they are asking how come the cations form these attractions. So then you have to say the metal atoms release their last shell electrons to form cations and a sea of electrons. And this strong electrostatic attraction between cations and the electrons are called metallic bonding. Explain why copper is a good electric conductor. 1 mark. So it has. So you are going to say it has delocalized electrons. You know that I like this delocalized word. Delocalized electrons which can carry the charge. Which can carry the charge. Right. Describe how impure copper can be purified. Did you try to answer this? Very good. You can't, because this is under electrolysis lesson. When are you going to learn electrolysis? Next month.
Next month.
Yes, next month you will be doing electrolysis. Name an alloy that contains copper. Any answer?
Gold.
So bronze.
Bronze. Right. Is that all we have in this tutorial? Okay. So have
Excuse
a
me,
screenshot.
sir.
Yes.
So there's
So
another
there's
page.
one more page, sir.
One more page. Okay, okay.
Yes,
Have a
sir.
screenshot of this and others confirm your answers.
So, for the C part, what is the answer?
C part, bronze. දැන් හරි කම්මැලි ළමයි ආපහු මේ ඉඳගෙන උගන්නනවා කියන එක හරි කම්මැලි වැඩක් නැත්තම්. Don't tell me the other way around. So ඉඳගෙන ඉගෙන ගන්නවා කියන එකත් හරි අමාරු වැඩක් කියලා කියන්න එන්න එපා.
So on the bright side, we at least get to learn something.
Okay. Okay, no, so shall we go to the question number 7? Only one person said understood. Others, oh, them may. Videos දාන්න නැති අය කිසි support එකක් නැහැ. I told you, no, okay, fine. You can't put the videos. I know you gave me the answer, but you can send me a especially those who haven't put the video on. Those who are with the video, I can see from your body language, right? Certain areas that. Okay, so next, let's go to the question number 7. Explain why magnesium reacts with hydrochloric acid, but copper doesn't. Even though we haven't done the reactivity series yet, this is a common thing I have explained to you in the reactions of acids or reactions of metals. Therefore, I'm going to explain, right? When magnesium reacts with HCl, you should get magnesium chloride and hydrogen. Yeah, Bindu, you want to say something?
No, sir.
Okay, right. And if you assume copper is going to react with HCl to give copper chloride and hydrogen, that is not possible. Reason, you can see magnesium has displace, you call it displace hydrogen. Displace hydrogen, right? Okay, I better put the arrow for hydrogen from reactant side to product side. That makes it more like clear in the point. So you can see the hydrogen here is H plus. Here hydrogen is 0. So hydrogen is displaced, right, by magnesium. For that to happen, magnesium should be more reactive. This should be more reactive than, I mean, the element should be more reactive than the displaced element. This should be less reactive, right? So in order to displace an element from its ion form like this, the other element has to be more reactive. That's the argument. More reactive means it should be above reactivity series. So magnesium is above reactivity series, so then it can do it. But copper is below in the reactivity series. We'll be doing reactivity series also in upcoming lessons. So then that's why copper cannot. You can say copper is less reactive. Copper is less reactive than whom? Not magnesium. Harida. Less reactive than hydrogen. So it can't displace hydrogen from acid. Is that clear? Magnesium is more reactive than hydrogen, so it can do it. Right. Let me explain it fully and then give some time for you to write it down. Huh? So the alloy brass is made of copper and zinc. The relative strength is increasing with what percentage? With the percentage of what? Is the percentage of copper or is the percentage of zinc? Hello. With what?
Percentage of zinc.
Percentage of zinc, right? So then how does the composition of brass affect the, when you had to say when, I mean, when the percentage of zinc increases, the strength increases. You have to write a full answer like that. Strength increases. All right. Not only that, sometimes in the exam, these are important things. Now these are not AO1. These are AO2. AO2 questions. AO2, right? We call them assessment objectives. Right? That means AO2 is not checking your knowledge. AO2 questions are not checking your knowledge. They check only your ability to handle information, right? So then they ask these trend questions mainly under AO2 assessment objectives, right? Sometimes they give you not 1 mark, they give you 2 marks. In that situation, not only that you have to say it increases with the percentage, you have to find whether there is a pattern. For example, when this increases by, when it increases by 10, then the other one is increases by this amount, whether you have a pattern like that. For example, here it's increases by 4, this is by 3, this is by 3. So then there is not like exactly same pattern, but you can still say when the percentage increases from 10 units, the strength has increased by approximately 0.4 units, 0.3 units, or approximately 0.3 or 4 units. Sometimes they ask the answer like that. Not only when the percentage increases, the strength increases. They ask quantitatively, right? Yeah, Nithuki, you have a question.
So shouldn't we also include how alloys are stronger than pure metals?
You mean in this question?
Yes.
Answer for this question? No, no. Nithuki, that is coming under description. The question word called describe, or the question word called explain. Then you have to refer to structure.
Okay.
But here the question word is, how does the composition of brass affect the strength? So they are not checking your cognitive ability. I mean, the comprehension, right? Your knowledge. They don't check that. They want you to see how the numbers change. And is there if the number is the number of the other parameter changes in the way that whether there is a correlation between those numbers. Do you get it? So it's a very important pattern we need to understand. Okay. So use the knowledge of the structure of metals to explain why brass is stronger. So you draw this, right? You draw few metal cations with a regular structure, and then few metal cations with bigger size. No need the electrons to be shown in this alloy diagram, but if you show the electrons, it's not a big problem. And then you have to say different size atoms. The different sized atoms block the movement of layers or sliding of layers. Right? And they ask label diagram. Right? So then you have to say here we have copper and the big fellows are zinc atoms, right? Because when you increase the zinc amount only, the strength is increasing. Have a screenshot also and then write down your answers. Then give me the confirmation about your understanding.
So, different size atoms block the
Movement
movement
of
of
layers. Yeah, movement of layers, cation layers. Okay, I think there was a glitch from my side. It says different size atoms block the movement of cation layers. So atom layers. Okay, Vidul, can you hear me?
Yes, sir.
You can say movement of cation layers or atom layers.
Excuse me,
All
sir.
right. Yeah.
So like in the first one, so like where the question on the top said that explain why magnesium reacts with hydrochloric acid, but copper does not, sir. In that, sir, you told that copper is less reactive than H2, sir. Therefore, it can't displace it, sir. Like it can't display it can't displace the hydrogen only in dilute hydrochloric acid, right, sir?
Actually, it is applicable for dilute acids. Applicable for dilute acids. Any dilute acid. Not only hydrochloric, any dilute acid.
Ah, okay, sir.
I mean, displacing hydrogen is not possible. It doesn't mean that the copper never reacts with any acid, right? It can't displace hydrogen. Yeah, Binuk.
So in that last part, sir, it says block the movement. Then sir, it's not clear.
Movement of block the movement of cation layers. So block the sliding of layers. ඉතින් ඕක මේ copywriting කරන්න බලන් ඉන්න එපා කියන දේ අහගෙන mind එකට අරගෙන ලියන්න. I am not writing the whole note on this. Vinu Kapu, don't try to go back to that kindergarten level.
Okay, sir.
Idea එක දුන්නම compose කර ගන්න answer එක. Okay, so that's all about this metal thing. In addition to that transition metal stuff we discussed last day, and also we have already discussed these transition metal things in the previous periodic table lesson. Now we'll move into the as I told you, the revision part of the calculation lesson. Right, I'm going to give you again very simple calculation again, right? To recall most of the stuff that we have learned. Am I clear? So here is the question. You can write the answers and send me that in the WhatsApp as well. Right, first of all, listen to me, because I'm not going to write that very clearly, which is little difficult in this. Right. So here I have dilute HCl of concentration, let's say 0.2 moles per dm³. This is the HCl concentration. Okay. And I'm going to put copper carbonate solid. Right? Copper carbonate solid. Question number 1. What is the wait, listen, you have to take part in the discussion. And I have 100 cm³ of HCl solution. What is the only question I can ask here in calculations?
Moles of dilute HCl.
So the concentration.
Concentration එක දීලානේ තියෙන්නේ.
So we
So
can
the
find
number
the
of
moles
moles.
of HCl.
Moles of HCl, correct. Before before everything, I have to give the what? Give the balance chemical equation. Now, අද මම equation එක දෙන්නේ නැහැ. ඔයගොල්ලෝ ලියන්න ඕනේ. හරි. Give the balance chemical equation. Second, number of moles of HCl. Third question, what sort of question I can ask as a third question? Yes, number
To
of
find the moles of copper carbonate.
copper carbonate needed to react, right? Needed to react. Then I can ask not number of moles, I can ask what
Mass
is
of
the
copper carbonate.
mass of copper carbonate needed to react. Very good. And this will give you copper chloride solution. This is going to give you copper chloride solution. Okay. And also it will give you carbon dioxide out. Then question Our calculation question
Sir, volume of carbon dioxide.
Okay, first of all, moles of carbon dioxide. Moles of carbon dioxide produced. Then volume of carbon dioxide produced. How question
So for the fourth one, what is the question?
Mass of calcium copper carbonate needed to react. මං කිව්වා අහගෙන ඉන්න කියලා ලියන්න නැතුව එතකොට තමයි ඔයගොල්ලන්ට තේරෙන්නේ මොකද්ද මම ලියන්නේ කියලා. හරි නේතුකි? Yeah.
So how do you get copper chloride if copper doesn't displace hydrogen?
This is not copper, no dear. This is copper carbonate.
Right.
This is the exact reason why I gave you this example. I know you will be thinking about it. How come now copper carbonate is reacting with HCl if copper can't displace? This is not a redox reaction to give hydrogen. This is a carbonate reacting with acid. Always give you salt, carbon dioxide and water. All right?
All right.
Okay, okay, right. Another question?
Sir, moles of CuCl2.
Very good. Moles of CuCl2. සන්දේ හොඳයිනේ. එකපාරට ලොකු වෙනසක් වෙලානේ. Huh? Right. තමුණා දාන්න පුළුවන්.
Next you sir.
Okay. තමුණා දාන්න පුළුවන්. Moles of CuCl2 and it's a solution. So then what you can find?
Concentration of CuCl2.
Concentration of Cl.
Concentration of CuCl2. Very good. Right? Okay. Here. Wait. I'm going to add more things. Suppose someone has crystallized this to obtain copper 2 chloride. Copper 2 chloride solid. So then not only concentration of the solution, what else I can ask? You are getting like solid at the end after crystallization. Yeah.
Mass.
So the mass of Cl.
We can find the
crystal
mass of
Mass of copper chloride. මෙතන ළමයි අහගන්නේ mass of copper chloride කියලා විතරක් ලියලා ඉවර කරන්න බෑ මේ question එක. You can't just write mass of copper chloride. This mass is a special mass. What is this? Mass of copper chloride expected in the reaction. Expected in the reaction, right? Or you can call this what? What else? Oh, something happened. Give me 1 minute. What do you call that mass? It is a special mass. What is that?
So it's a mathematical value.
Theoretical math.
Mathematical.
Theoretical value.
The
Theoretical. What?
theoretical math.
Theoretical yield. What do you call it?
Theoretical yield.
Theoretical yield.
Theoretical yield. You call it theoretical yield. All right. So let me give you good 10 minutes to write this and do the calculation and send me the answers. All right. 10 minutes වැඩිද? 5 minutes විතරක් දෙන්නද?
10 minutes
Most of
under
them is
හරි. Okay. Right. හරි. අංකල කරන්න. Just for 5 minutes, I'll be out of my seat. Okay. By the way, have a screenshot. Okay, let me see your answers. Not yet, right?
Sir, for the 8th question, you haven't given a volume of copper chloride, right?
When a solid reacts with solution, there was a question like this earlier also. Can you remember? දැන් එතුක හිතන්නකෝ තව ටිකකින් මේ අම්මා ගෙනත් දෙනවනේ ටී එක බොන්න නැද්ද? හරි නිකන් assume කරන්නකෝ. හරිද? හා දැන් ටී එක හදනවා 100 milliliters වලට. හරිද? 100 milliliters වල හදලා ඒකට you are going to put 1 spoon of sugar. Would the volume change? No, right?
Okay, sir.
Okay, you got the point. හැබැයි මෙහෙමයි. If it was a cordial made, that's a different story. You are going to mix, let's say 10 ml of cordial syrup into 100 ml of water. The total volume going to change. But when you dissolve solid, there is no significant change. I should go to my paint teaching, no? Teaching using paint. Well,
So should we take chlorine as 35.5 or 36?
35.5. That should be 35.5. By the way, did you write the reaction? If you don't write the reaction properly, you are in trouble. Huh? Let me give you the reaction as an answer. Otherwise, I feel like you're going to do all the calculations with the wrong stoichiometry. So that's a reaction. Just check whether you are correct. And ignore, I'm doing a rough calculation over here. Please ignore that.
So I sent you my answer.
You send your answers. All the answers. You did.
Yes, sir.
Sir, I also sent.
Okay, Nithuki has sent the answers. Devin to send the answers.
There is no 10th question, right?
I'll be putting a 10th question.
Okay.
Sir, have you
Excuse me, sir.
Yes.
Sir, have you got 2 pictures or only 1 picture from me?
1.
Okay, sir. The other one I sent it.
Okay.
Sir.
Yeah.
Sir, to find the concentration of copper chloride, sir, you haven't given any volume, no, sir.
Same question Netugi asked.
තමන් ඒ වෙලාවේදී අහන් හිටියේ නෑ.
ඒක තමයි අහන් ඉන්න ඕනේ. මම කාට හරි උත්තරයක් කියනකොට තමන් ඒකට attention එක දෙන්න ඕනේ. මම නෙතුගෙන් ඇහුවේ ඔය නෙතුගිගේ අම්මි දැන් මොකක් හරි තේ එකක් හදනකොට 100 ml water වලට sugar spoon එකක් dissolve කරාට volume එක change වෙනවද කියලා ඇහුවේ යාගේ. And then
okay, sir.
she didn't answer. She just realized what to be done.
So can I correct my answer?
Is this Devindu?
Yeah, sir. One is wrong.
Them back. I have already taken them onto the board. All right. And anyway, Lamai, when you are sending me the answers, please make sure they are cropped, turned, so that I can directly use them in the discussion. Okay, here we go. Here we go. Can you see the answers?
Yes, sir, but they're very small.
They are very small. I'm sorry about it. Can't help. Right. I will write the answers also. Okay. So the first one, moles of HCl 0.2 into 100 divided by 1000, which is 0.02 moles. Right. And Devindu's answer is correct. And Netugi's answer is also correct. And moles of copper carbonate, HCl to copper carbonate ratio is 2:1. Therefore, now we know that HCl mole 0.02x. So x is going to be 0.01. That's the moles of copper. That's the moles of copper carbonate. Once you know the copper carbonate moles, you can use M over capital M. 0.01 is equal. M we don't know. Capital M here is 124 according to copper 64 the tipe. Oh, ne?
Yes.
So then it's 1.24 grams. So that's correct.
Yes, sir.
Let me see Devindu's answers. Good, good, well done. And then the moles of carbon dioxide, right? Again, the ratio CO2 to copper carbonate. Now she is going to use copper carbonate moles. Now be careful with this, right? You initially started with HCl moles. It's easy with HCl. This is also not wrong. It should end up with the say correct answer. So moles of carbon dioxide should be 0.01. Or this should be done in this way as well. This can be done in this way as well. You found this is 0.02 and this is x, and x is 0.01. Right? So that's the fifth one. Okay, maybe some of you are sending me the answers as well. Right? That's good. I'll have a look at it. Anyway, let me explain these ones also. So 0.01, and then the volume of carbon dioxide, of course, it should be N equals V over 24. If anyone doesn't see the answer, N we know 0.01 V over 24, and then V is going to be 0.24 dm3, which is 240 cm3. This is correct. This is correct. Things go well now, right? And then you have to find out the moles of copper chloride. So you have to use a ratio. She has used copper chloride and copper carbonate. So this is X, this is 0.01 moles. Therefore, the moles will be 0.01. That's copper chloride moles. So is that the same answer with Devindu? Devindu is so far so good. Maybe in the last one you made mistake, right? And in the last one, that's the volume case. Lamai, this is a solution. You must use what? N equals CV. You can't use N equals VO24. Right? So then this is going to be 0.01. Concentration, we don't know. Volume is still 100. Right? So then that is divided by 1000. Concentration will become 0.1 mole per dm cube. Right? That's good. 0.1 either. Point on the point one, no? This is wrong, right? This is 0.1. It should be 0.1. Right? Silly mistake. And finally, the mass can be calculated using N equals M over capital M. Right? So the mass that you are going to get, theoretical mass is 1.35 grams. Right? For this, I need confirmation from everyone without failing. If you have questions, you can ask. Hurry up, take a screenshot of this.
So not 1.35, then it becomes 13.5.
Why? No, it's 1.35. Nine idea. Okay. ඒක concentration එක නේ වෙනස් වෙන්නේ. Moles නෙවෙයි. So your answers, only the concentration went wrong. Others quickly confirm whether you are all right with this discussion. And let me add the 10th question here, which I want, I want everyone to find the answer. Suppose experimentally 0.7 gram of copper chloride crystals made. Crystals were obtained. Then what's the question?
Find the percentage yield.
Yes, very good. Yes, yes. Find the percentage yield. Find the percentage yield. I can answer one bantagal. We were planning to have a practical session this Saturday, right? All of the sudden this
So I put the answer.
19.29%, Lashay. Where did you put the answer, Binuk?
Sir, to WhatsApp.
Hari me final answer එකක් එවනකොට WhatsApp එවන්න ඕනේ නැහැ anything.
Sir, I put my answer.
Chat එකේ දාන්න පුළුවන් ඒක. %52%. Yeah. Lashin 19.29 කොහමද ආවේ?
So I use 1.35 grams.
So what's the equation? Percentage yield is equal to what?
Sir, Lashin has divided 1.35 by 0.7.
එතකොට එන්නේ
So in 19.
19 point ගාන නෙමෙයි එතකොට එන්නේ. එතකොට එන්නේ 192.
192.
Right?
No,
Pretty
sir,
much.
1.92.
ඒක 100 වලින් වැඩි වෙන්න එපයි බිනු percentage yield එක හදනකොට.
Yes.
හරි බලා ගන්න ලෂෙන්. Lashin, stop your and look. Percentage yield is equal to what? Experimental yield divided by theoretical yield into 100.
Yes, I messed up the equation.
Yes.
Now it's 52%.
Yeah, it's 0.7 divided by 1.35 into 100. So this question basically has all sort of things we have learned under calculations, isn't it?
Yes,
All
sir.
sort of things that we have to learn under basic calculation skills, right? So if you are in a position that you understood all the 10, I mean your answers are correct, all 10 answers for all the 10 questions are correct. Maybe careless mistake is there, but the method you have used correct, you can be really happy, honestly. Because there can't be anything, I mean, more than that, except for the one that I'm going to explain you next, right? So you have mastered your calculations in Cambridge O-level 5070 syllabus, right? So you can be really happy. Okay, if there is a person who didn't get everything correct, but you understand everything after I explained it, you can be also very happy. Because you know what's happening in the calculations, right? If not, you are not up to the standards yet. We'll check why you are not up to the standards. Let me tell you why. Some of you have forgotten equations, relationships. That's one way you get. The other way, right? You don't think critically, right? That means, okay, now I have to find the moles. So I have to use the stoichiometry, or whether I have to use the equation, right? You don't think critically, right? So then those things have to be, corrected with time. But don't worry, right? If you go through the lessons again, try more questions. If you have the willpower to do that, you can definitely improve. All right. Okay. So here we have Vidul ගොඩක් වෙලාවකින් interact කරේ නෑනේ. You didn't respond me in the chat, as well as like you switched off the video. That's all right, because I know you are using mobile phone, but
Hello, sir.
I want you to. Okay. Right. Shall we move on
Yes, sir.
to Hari Vidul? Okay. let me go to the next or the new topic. Right? Before I give you the topic, let me give you a question. This is the question. Don't rush. I don't want you to rush here. So there I have, like, again HCl. Concentration is 0.2 moles per dm cube. Volume is 100 cm cube. Okay. දැන් මේ කරපු question එකමයි ළමයි මම මේ දෙන්න යන්නේ. Right? The same quantity. I'm giving you the same quantity. HCl. And suppose I am adding sodium hydroxide. Solid sodium hydroxide. The amount of sodium hydroxide that I'm going to add here is 1 gram. I'm going to add 1 gram. All right. Okay. Tell me where is the start of all the calculation in this question?
So moles of HCl.
Moles of
The
HCl.
balance equation.
Balance equation. That's correct. Anyway, balance equation is given to you. Is given to you. Okay, now Tevindu said, Tevindu the kiwi. The Netil.
Netil.
Netil. Okay. Netil said moles of HCl. Anyone else? Can't we start the calculation in anything else here?
The moles of sodium hydroxide.
Moles of sodium hydroxide. So can't you find the moles of sodium hydroxide here?
Yes, sir.
Can't you find the moles of HCl here? Neither. You get my point? So
Yes.
Don't you feel the question has too much of data? The question is
No, sir.
right, but question is confusing us. No, why? Only HCl amount is needed. I mean, needed to find the amount of sodium hydroxide. Why are they giving amount of both reactants? They are confusing us, aren't they? Okay. Do you agree with my point or not?
Yes, sir.
Right then, දෙකේම quantities දීලා තියෙනවා. දැන් මොකකින් පටන් ගන්න කියලාද හිතා ගන්න බෑ නේද? So what I'm going to do, I'm asking you to forget sodium hydroxide. Forget. Or a better word, ignore. Ignore sodium hydroxide. Shall we ignore sodium hydroxide and do? Okay.
Okay, sir.
Amara kemati wage sodium hydroxide ගෙන් පටන් ගන්න. Right. Shall we find the moles of HCl? Easy. N equals CV. Concentration is 0.2 into 100 divided by 1000. You end up with 0.02 moles. Do you agree with this?
Yes, sir.
Second, if I ask moles of sodium hydroxide, now I said ignore the amount. Sodium hydroxide amount ignore කරන්න කියලා කිව්වනේ. මේ දීලා තියෙන amount එක ignore කරන්න. මේක ignore කරන්න. හරිද? Because it's confusing us. All right. Moles of sodium hydroxide needed. We can do that using HCl moles. Kitumi, do you understand that moles of sodium hydroxide needed can be calculated using moles of HCl? You understand that?
Yes, sir.
I didn't hear you.
Yes, sir.
Yeah, what do we use? Stoichiometry. So when I apply stoichiometry, what is the moles of sodium hydroxide needed here? Can you quickly use
0.02.
0.02? Very easy, right? So this is sodium hydroxide needed. Let me write this as needed, stoichiometrically needed. Now we are, as a third point, we are going to look at the ignored quantity. Let me say moles of sodium hydroxide used. Moles of sodium hydroxide used. I can use N equals M over capital M for that. Right. So how many moles use? 1 gram divided by molar mass of this. 40 grams per mole. How many moles we use?
0.025 moles.
0.025 mole. This is used amount. Do you have any comment to make about moles of sodium hydroxide needed and the moles of sodium hydroxide used? Janila?
Sir, if we only need 0.02, why do we add another 0.005 moles?
Yeah, Janila?
Yes, sir.
Oh, mama prasnaya kya hua? Janila te ada nikan cool එකේ වහිනවා. නිකන් කම්මැලි හිතලා වගේ ඉන්න නේද? නැද්ද Janila? Yes, the no, the Janila.
But sir, at least I didn't hear the question properly.
ඒකනේ. වාගේ. හරි. Janilට ඇහිලා නැහැ question එක. මම හිතන්නේ ජනිල hina වෙනකොට කන් දෙක වැහෙනවද කොයිද ඒකයි. Right, okay. Let me ask the question again. I asked, what is the comment you can make on these two quantities? Moles of sodium hydroxide needed. That's the normal stoichiometric amount. This is the moles of sodium hydroxide used.
So that's two different values and it can change.
Okay, two different values. Okay, let me ask this now. The මොකක්ද මේ value එක? Janila? What is
Sir,
this?
it's the experiment, theoretical one.
Stoichiometric one. Hari,
Yes, sir.
theoretical කියන්න පුළුවන්. Hari. That's the needed amount, right? The may value එක මොකක්ද මේ? මොකක්ද මේ value?
So can we call the experimental one?
Good. The actually used amount. Right? So tell me whether our actually used amount, actual amount we have used, compared to the needed amount, which one is higher for sodium hydroxide?
The needed one.
So the needed one.
On the test සරලා බලන්න.
So the actual amount is high, sir.
Sorry, the
Because it's
used one, the actual amount.
0.5. Needed is low.
Stoichiometric value එක අඩුයි නේද? Stoichiometrically වාට ඕනේ 0.02. හිතන්නකෝ cordial එකක් හදන්න ingredients mix කරන්න ඕන ratio එකේ දීලා තියෙනවා add only 2 spoons of cordial. ඔයා දානවා that's the theoretical amount, right? It's given in the recipe, all right? And you are going to add 3 spoons of cordial. Have you added limited amount or an excess amount?
Excess.
Excess.
You have to get into the discussion, like even the students who are not with the camera on. You have to respond my questions, general questions, right? For Ranubi, no answers in the chat for any reason, like when I ask those questions. Oh, him back, neither. Right? When I ask, okay, the recipe says put two spoons of cordial, but you put 3 spoons of cordial for the same volume of water. So do you call you have added a limited amount of cordial or excess amount of cordial? What do you call it?
Excess amount.
Excess mass. Excess amount.
You have added excess amount. So in this case, sodium hydroxide, stoichiometrically you need to add 0.02. You actually have added 0.025. Have you added sodium hydroxide in excess or is it limiting?
So in excess.
Others? Is sodium hydroxide in this situation you have added excess or limiting?
So we have added in excess.
You have added in excess.
Excess.
දෙවිඳු මුලින් excess කියලා ඊට පස්සේ limiting කියනවා. දෙවිඳු
So it's like Sri Lankan politicians change parties at wheels.
අම්මෝ යාස. Same.
අම්බෝ politics ගන්න එපා ළමයි මෙතනට ගන්න එපා. I have told you that's the most toxic topic that we could ever talk. Right? මොකද දන්න reason එක? ඒත් ඕනේ නෑ ළමයි ඔන්න කල්ලා දාමු. Right?
අනේ සර් කියන්නකෝ.
එක්ක ඕනේ නෑ ළමයි මෙන්න මේ කරමු.
සර් කියන්නකෝ.
ළමයි අපි මේ exam අරගලය කරමුකෝ. ඔය මේ මොනා කරන්න කලින් හරිද?
The limit means you meant limiting factor or
මොකක් වුණත් කමක් නැහැ. Limiting reagent, limiting factor, anything. So you can see you have added more amount than needed. ඔයගලන්ට මම මගේ political point එක එදා කිව්වනේ point of view I told you in the class, right? What do we have to do? So I don't want to waste any more second telling that. You can see the drama is nicely happening, right? As I told you always, it's a complete drama. The script is nicely running. Now the final episode is there, right? And you can understand it's a properly written script, right? Okay. අපි පස්සේ කතා කරමු ළමයි ඔය. අපි තරහ වෙනවා. Okay. හරි. So you have actual amount more than the needed amount, right? Therefore, I can call sodium hydroxide is the reagent in excess. Reagent in excess. Reagent in excess. How do you find whether sodium hydroxide is reagent in excess? What is the first thing you have to do? මේ calculation එක කරනකොට මුලින්ම කරේ මොකද්ද?
so found the moles of HCl.
No. What was the first thing we did?
They ignored NaOH.
So we ignored NaOH.
We ignored NaOH. If you are going to consider both of them and do the calculation at the beginning, that's the end of you. Right? So you have to ignore one reactant if they have given the amount of both reactants, right? So then how do you find whether it's limiting or excess? Ignore the amount of one reactant. Is that clear? Okay. Second,
Yes, sir.
what's the second step? Find the
So
moles
find
of,
the moles of the other one. Other
correct.
reaction.
Find the moles of the other one. Other one. What's the next one? Use
So then find
stoichiometry. No. First, use stoichiometry to find, listen to me very carefully, find the moles of, find the needed moles of ignored one. You got it?
Yes.
Yes, sir.
What's the fourth
Yes.
step?
So
The
then
next
find the
step, find
moles
the
of the
mass of
ignored
the
one.
ignored.
No, find the moles of,
Moles of
find the added moles. Added moles of ignored one. And what is the fifth step? Compare the needed and what? Added amount
used.
or actual use or added amounts. If the added amount is higher, it's in excess. If the added amount is less than needed, it's going to be what? Limiting. You get the point? So in this situation, your sodium hydroxide is reagent in excess. Then who is the limiting reagent? Who is the limiting reagent in this reaction? Come on, guys, talk like. If sodium hydroxide is a reagent in excess, this sodium hydroxide is a reagent in excess.
So the needed value.
So who is the limiting reagent? How do you say it's again sodium hydroxide? You can't say that. It's HCl. Is that clear? Right? Okay, what are
Yes.
the 5 steps again? First of all, ignore the amount of one reactant. Then find the moles of other reactant. Therefore, let me put the numbers according to the way that I wrote down the procedure, right?
So when ignoring, sir, we can ignore any of the two, right?
Yeah, any of the two. Exactly. Okay,
Okay.
you are on the track. You can start anywhere you want. Okay, here is the first step. Ignore sodium hydroxide. Here is the second step. Find the moles of HCl. Here is the third step. Find the moles of sodium hydroxide needed. Here is the fourth step. Find the second step. Third step. Find the added moles of sodium hydroxide. And here is the fifth step. Compare them and decide. And they're not either. Is there anything new
Yes,
here?
sir.
Apart from the limiting reagent story, is there any new equation used?
No.
No, right? It's the same like N equals M over capital M or N equals CV, stoichiometry, same thing. Just put in different ways. Yeah, Nithuki, you can ask.
So if NaOH is a limited factor, then automatically HCl become sorry.
Of
If
course,
NaOH
of
is
course.
excess,
Yeah,
then the other one will be the limiting.
yes.
Alright.
If sodium hydroxide, when you calculate this, just in case if you get the inequality other way around, right? That means so needed amount is more than the actually added amount. That means you haven't added enough sodium hydroxide. So it's limiting, right? You haven't added enough to react. So it's limiting, and the other fellow is the reagent in excess. Hari.
Okay, sir, thank you.
Liagat. Have a screenshot. Topic, limiting reagent and the reagent in excess. Topic, limiting reagent and reagent in excess. There is no reason for you to switch off your video unless you are using a mobile device. Okay, you are done.
Yes, sir.
Right.
Sir, when now we're doing acid-base titrations?
After May monthly test work. You
So,
mean titration? Did you say acid-based titrations or what?
yes, sir.
Titration next week.
Okay, sir.
It will be next week. I was planning a practical for that. No, Nathan.
Okay, sir.
Right. Shall we do the question number 2?
Okay, sir.
Under limiting reagent. So what you have to do, you need to find out what is the limiting reagent or reagent in excess. Are you ready? Right. So this is the system. Suppose we have 0.1 mole per dm cube HCl 100 cm cube. And I'm going to add calcium carbonate solid. Now, how much I'm going to add here? I'm going to add, suppose 0.8 grams. No, 0.8. 8 grams. Right? 8 grams. So you need to find out which one is the limiting reagent. Before I do that,
So, are you giving the balanced equation?
Yeah, let me give you the balanced equation. Calcium carbonate plus 2HCl giving you calcium chloride plus carbon dioxide plus water. Let me ask some questions. What is the first step? Wait, Ranumi, you need to answer me.
Sir, you had to first ignore one of the given data.
Okay. So which one you are going to ignore?
Calcium carbonate.
All right. So your plan is to ignore calcium carbonate. Then what's the second step?
Then you have to find the moles of HCl.
Moles of HCl. Right. Fine. That's enough. Then Shannon, what's your next step? According to the way it goes, Shannon, what's the next step?
Hello, sir.
Yeah, what's the next step?
So get the stoichiometry.
And find what? Stoichiometry and find what?
So the moles of HCl.
Moles of HCl is already found in step 2.
So the more
Moles of
moles of
calcium
CO3.
Calcium carbonate. But moles of calcium carbonate, what? Needed or added? Needed or added?
Needed.
Okay, so it's needed. Then what's the next step? Janila, no, Vidul, what's the next step? Vidul. Next step. Kian. What's the fourth step? Didn't you write the steps, Vidul, for the previous one?
I know.
Sir, can I?
Yeah.
So,
Okay. You find moles of calcium carbonate added. Now you have to use the ignored amount. Okay, Lashin, you can leave the class because I'm going to finish the class with the discussion of this question. Don't worry about, so you can go through the video only that this part. All right. Okay, so the moles of calcium carbonate added. Finally, what you have to do? Compare the added and needed amounts. All right. Let
Sir,
me.
can you tell again what is?
What?
Sir, can you tell again what is the limiting reagent like from the two? I didn't get them.
एक common sense, Nitin. If you have actually added something less than needed, so it's limiting, right?
Okay, sir.
Yeah, Binu, you can leave. But there are some students who left without telling me, right? Metum has left. And even Vidul is not there. Oh, Vidul is there. Vidul is there. Sorry.
I'm there.
Yeah, you're there.
Sir, should I send the answers in the chat?
Yeah, you can send me the answers WhatsApp or in the chat.
Okay, sir.
Okay, Temidu, you can go. Okay, shall we discuss the answers? So this theoretical, I mean the limiting and the excess one is very easy, not like previous one. I mean the same thing basically, right? So the moles of HCl, now you ignore the reactant, right? However, in the exam, don't write like this. Okay, Netuki? This is for your like convenience, but don't write that in the exam. Okay.
Okay, sir.
Moles of HCl is correct. Moles of calcium carbonate needed is correct. 0.005. Good, good. Nithil, I think you are still using. I mean, you're not using the calculator. Do you? Aren't you?
So I am.
You are using it. All right. Okay. Okay. Then it's all right. Okay. Then you find the mass of calcium carbonate. Sorry, moles of calcium carbonate used. And it's 0.08, but you need only 0.05. Then the actual amount is higher than theoretical may conclusion nigga. Right? The used amount is higher, therefore it's the reagent in excess. And HCl is the limiting reagent. Okay, Nitin. Conclusion?
Okay, sir.
All right. So here we have come to the end of all the calculation, right? Needed. So we'll do past paper question discussions on calculations next day. Right? If possible, we'll try to have a practical session. If not, we will go for virtual practical session. Most of the time, if it is virtual practical, it's going to be self-learning assignment, right? You know that depending on whatever the situation, we have to work, right? Whatever the country situation, right? Because that's the way we can survive always, right? Therefore, I will put a self-learning assignment on the titrations. If I'm not going to conduct the practical because of the situation, right? And then by next week, we can start off with past paper discussion and you guys will be like doing very well for your monthly test. All right. Okay, so let me wrap up the meeting now. I'll see you guys next week. Bye.
Thank you, sir.
Thank you, sir. Have a nice
Thank you,
day.
sir. Bye, sir. Good night.
Thank you, sir. Bye, sir.
Okay, bye.